Maps are powerful tools. They help us understand our world, but maps can't show everything. That's where map generalization comes in. It's like summarizing a long story. You keep the important parts and leave out the rest. Imagine a map showing every single tree in a city. It would be a mess. You wouldn't be able to see the streets or buildings. Map generalization helps us create useful and easy-to-read maps. It makes sure the important information stands out. Think about a road map. It doesn't show every bend in the road. Instead, it simplifies the route. This makes it easier for drivers to follow. That's map generalization in action. Map generalization is essential for all sorts of maps, from tourist maps to city planning maps. Generalization makes them clear and informative. Map makers use several methods for generalization. Let's explore a few. Simplification involves smoothing out complex shapes. For example, a jagged coastline might be simplified with fewer curves. This makes the map easier to read without losing essential information. Selection means choosing which features to include and which to leave out. For a city map, major roads would be included, but smaller alleys might be omitted. Aggregation combines similar features into one. Imagine a map showing houses. Instead of showing each individual house, they might be grouped together as a residential area. Displacement means sometimes features need to be moved slightly to avoid overlap. This is especially important for labels. Imagine a map with overlapping street names. It would be impossible to read. These are just a few of the techniques used in map generalization. By using these methods, map makers create clear and informative maps. Smart cities use technology to improve efficiency and quality of life. Map generalization is crucial for planning and managing these cities. Let's see how generalized maps can show traffic flow and congestion patterns. This information helps city planners optimize traffic lights and design better roads. Planning bus routes and train lines requires understanding population density and travel patterns. Generalized maps can visualize this data, leading to more efficient public transportation systems. In emergencies, every second counts. Generalized maps can help first responders quickly identify the fastest routes and locate critical infrastructure. Understanding where people live and work helps cities allocate resources effectively. Generalized maps can show population density, guiding the placement of schools, hospitals, and other services. Map generalization allows city planners to analyze complex data and make informed decisions. This leads to smarter, more efficient, and livable urban environments. Green infrastructure, like parks and trees, is vital for healthy cities. Map generalization plays a key role in planning and managing these green spaces. Generalized maps can show the location and size of parks, forests, and other green areas. This helps city planners identify areas where more green spaces are needed. Trees provide shade, clean the air, and reduce the urban heat island effect. Generalized maps can show the distribution of trees in a city, helping planners identify areas where more trees should be planted. Keeping track of thousands of trees in a city is a challenge. Generalized maps can help manage urban forests by showing the location, species, and health of individual trees. Creating green corridors that connect parks and other natural areas is important for biodiversity and recreation. Generalized maps can help planners design these corridors and ensure they are accessible to residents. By using map generalization, we can create greener, healthier, and more sustainable cities for the future.